Welcome students. The topic we are going to discuss is data reduction. A data reduction technique is used to obtain a reduced representation of the data set that is smaller in volume but it contains critical information. A data warehouse may store terabytes of data. It may perform a long data analysis and mining of such large amount of data. Data reduction is the process of compressing the large amount of capacity required to store the data. Storage vendors often describe the storage capacity by the terms of raw capacity and effective capacity. So, the data reduction may increase storage efficiency and reduce cost. Data reduction can be defined in many ways. They are data deduplication. Data deduplication is also known as data dupe, and it eliminates the duplicated segments of data on storage systems. It stores the redundant data only once and that copy can be accessed whenever the user requests the data. Data dedupe, that is much granular than single instance storage. The next one is single instance storage. Single instance storage finds all the files like small attachments sent to different people and it stores one copy of that file. The single instance storage replaces all the duplicates with pointers to the one saved copy. The storage arrays track the blocks which can be shared heavily. Those heavy blocks are shared by the number of files can be moved to a memory or flash storage. It is based on cache, so it can read as efficiently as possible. The next technique is data compression. Data compression on a file level is accomplished in storage systems which uses the algorithms or formulas designed to identify and to remove the redundant bits of data. It uses the data reduction method by shrunk the files at the bit level. It represents the data compression technique by using formulas of algorithms to reduce the number of bits needed. It represents a repeating string of bits with the smaller strings of bits and it uses a dictionary to convert between them. The next concept is data reduction strategies. Data reduction strategies applied on a complex data and mining, and it represents a huge amount of data can take a long time, such as analysis impractical or infeasible. Data reduction techniques are used to represent the data that can be applied to obtain reduced data and it can be more efficient to produce the same analytical results. The strategies used for data reduction are described below. The first strategy is data cube aggregation. The aggregation operations measure applied to the data within the construction of data cube. The combination of two or more attributes or objects into a single attribute. The data reduction. The main purpose is data reduction. It reduces the number of attributes or objects in the data reduction. For example, cities are aggregated into regions, states, countries, etc. The aggregated data tends to have less variability or more stable data. Data reduction sampling. Sampling is mainly used for the data selection. It can be used for both the initial investigation of the data and the final data analysis. Statisticians sample obtains the entire set of data of interest is very expensive or time consuming. Data reduction. Types of sampling. Simple random sampling. There is an equal probability given for selecting any particular item. Sampling without replacement. When the item is selected, then it is removed from the population. The next technique is sampling with replacement. When the samples are selected, the objects are not removed from the population. In this method, the same object can be picked up more than once. The next technique is data reduction by sampling method. It allows a mining algorithm to run in complexity that is sublinear to the size of the data, choosing a representative subset of the data. The simple random sampling can have very poor performance in the presence of skew. So, it develops adaptive sampling methods. The next concept is stratified sampling. It approximates the percentage of each class or subpopulation of interest in the overall database. It uses conjunction with skewed data sampling, cannot reduce database input or output pages at a time. The second technique is attribute subset selections. In this strategy, the irrelevant data, weakly relevant or redundant attributes or dimensions may be detected and removed. This technique is to reduce dimensionality of the data. Next concept is redundant features. It duplicates most of the information contained in one or more other attributes. For example, the purchase price of a product and the amount of sales tax paid. The next concept is irrelevant features. It does not contain information that is useful for the data mining task. For example, the student ID is often irrelevant to the task of predicting the student's CGPA. The third technique is dimensionality reduction. In this method, encoding mechanisms are used to reduce the data set size. Curse of dimensionality. The dimensionality of the data increases, data becomes increasingly sparse. The density and distance between points, which is critical to clustering, outlier analysis, becomes less meaningful. The combinations of subspaces will grow exponentially in dimensionality. The next concept is dimensionality reduction. It avoids the curse of dimensionality. It helps to eliminate irrelevant features and reduce noise. It reduces the time and space required in data mining. The visualization is easily allowed. The next concept is dimensionality reduction techniques. The dimensionality reduction techniques are wavelet transforms, principal component analysis. This technique extracts some amount of features from the original data set. These extracted features or variables are called as principal components. The next technique is supervised and nonlinear techniques. Next we are going to see about numerosity reductions. It is where the data are replaced or alternative smaller data representations such as parametric models or non-parametric methods such as clustering, sampling and use of histograms. It reduces the data volume by choosing alternative smaller forms of data representation. The next technique is parametric methods. The parametric method assumes the data fits some model and estimates model parameters, stores only the parameters and discards the data except the possible outliers. For example, log linear model obtains value at a point in multidimensional space as a product on appropriate marginal subspaces. The next concept is non-parametric methods. The non-parametric methods do not assume models. The major families are histograms, clustering and sampling. The parametric data reduction. Linear regression. This data model fit a straight line. It uses the least square method to fit this line. Next concept is multiple regression. It allows the response variable y to be the data as a linear function at multidimensional vector. The next concept is log linear model. It appropriates the discrete multidimensional probability distributions. The next concept is regression analysis. This technique is used for the modeling and analysis of numerical data. The numerical data consisting of values of a dependent variable or independent variable. It is used for prediction including forecasting of time series, inference of hypothesis testing and modeling of causal relationships. These parameters are estimated and gives the best fit of the data. The best fit is evaluated by using the least square method. The next concept is regress analysis and long linear models. Let us see about linear regression. Consider the formula y is equal to wx plus b. Here w and b are the two regression coefficients that will specify the line and are to be estimated by using the available data. The next concept is multiple regression. Here consider the formula y is equal to b0 plus b1 into 1 plus b2 into 2. Many nonlinear functions can be transformed in multiple regressions. The next concept is log linear models. It is the approximate discrete multidimensional probabilistic distribution. It estimates the probability of each point in a multidimensional space for a set of discretized attributes based on a smaller subset of dimensional combinations. It is issued for the dimensionality reduction and data smoothing. The fifth concept is discretization and concept hierarchy generation. In the discretization, raw data values for attributes can be replaced by range or higher conceptual levels. Data discretization is useful for the automatic generation of concept hierarchies. Discretization and concept hierarchy generation are powerful tools for data mining, in which they allow the data mining to multiple levels of abstraction. The next concept is top-down discretization. This process initially finds one or few points to split the entire attribute range, and then it repeats this recursively on the resulting intervals. Then it is referred to as a top down discretization or splitting. The next technique is bottom up discretization. This method starts by considering all of the continuous values as potential split points, and it removes some by merging neighborhood values to make intervals. Then it is called as bottom up discretization or merging. There are many typical methods, and that methods can be applied recursively. Next concept is binning. Binning may be a top down splitting technique based on a given number of bins. Binning is an unsupervised discretization technique. The next technique is histogram analysis. Histogram analysis would not use class information, so it is an unsupervised discretization technique. The next technique is cluster analysis. The cluster analysis uses data discretization method, a clustering algorithm applied to discrete and numerical attribute by partitioning the values into clusters of groups. The next concept is discretization by classification. Correlation analysis is the next topic. So, classification, the example is decision tree analysis. The next concept is supervised classification. The given class labels, for example, cancerous versus benign, using entropy to determine split point, top down or recursive split. The correlation analysis, for example, chi-merge X2 based discretization. The supervised discretization, it uses the class information. The next one is bottom up merge. It finds the best neighboring intervals, that is those having similar distributions of classes. It is to merge. The merge performed recursively until a predefined stopping condition. The next concept is data reduction for primary storage. Data deduplication was first developed for backup data on secondary storage. It is possible to deduplicate the primary storage. Primary storage deduplication can occur as a function of the storage hardware or operating system. Windows Server 2012 and Windows Server 2012 R2 have built-in data deduplication capabilities. The deduplication engine uses post-preprocessing deduplication, which means deduplication does not occur in real time. This scheduled process periodically deduplicates primary storage data. Conclusion: data reduction is a process to convert polluted, unmanageable or duplicate data into final meaningful data for any organization. Duplication of record is a serious challenge in data warehouse. It makes out performance slow and reduces our storage capacity. To get rid of this problem, we use data reduction techniques, algorithms and tools. There may be various reasons for this duplication issue, which can arise due to integration of data at various steps of our end-to-end cycle of data migration. When we collect data from different sources and integrate it, then we find some data may be identical or seems identical. Duplicate reduction is very difficult to apply in real world. In continuation of past work, purposing an algorithm which uses the cluster for comparison of record. A cluster contains sets of records. Each set contains one or more data from a detected cluster. Entire clusters should not always be saved due to efficiency reasons. Thank you.